So I've got an axial piston pump apart here. While the component names and functions are fresh in our minds, we want to just have a look at this pump, and I'm just going to talk about some common failures of piston pumps. I'd mentioned before that because of the tight tolerances between the parts, cleanliness of the oil now, when we introduce piston pumps to a hydraulic system, has to go up. The game for maintenance has to be played a lot more diligently. Filters have to be changed on time, oil has to be changed on time as well, and oil sampling should be part of a regime, as well as cutting open filters to make sure we don't have any contamination that's going to affect some expensive components like this piston pump. So of course we've got our swash plate here sitting on a couple of saddle bearings. And it's a variable displacement pump. As you can see, the swash plate moves. There's some actuators here in the pump housing that are going to move that swash plate. And then we've got the shaft. When I look at the shaft, I'm looking at the spline, and it doesn't look like there was a lot of hours on this pump, because the spline wear on the shaft and the spline wear on the barrel seems to be pretty much zero. The parts in there look pretty much new. There's our spring coiled up inside the barrel to preload the slippers onto the swash plate. And then as I look around, here's our ball guide again. And when I pulled the pistons out of the barrel, I noticed that one did not want to come out. It was staying in the barrel, and when we took this retraction plate off, we found out that one slipper was not attached. So sometimes people call this a Cinderella pump, because it's missing one of the slippers from the one piston. So, question is going to be immediately, what caused this pump failure? Why would that slipper be detached from the piston? And the evidence is right here. You can see that piston is quite jammed in the bore of this pump. So as the piston pump is rotated by the shaft and the barrel turns, as the pistons are being retracted from the barrel, that's of course the job of the retraction plate or the retainer plate, which is this plate that supports. It also spaces all the slippers out, and it also transfers that energy from the ball guide and the spring inside the barrel to the slippers to preload them against the swash plate. So as the pistons are being drawn out, you can probably imagine what would happen if one piston was seized inside the barrel. The two neighboring pistons are wanting to follow the angle of the swash plate and the rotation of the retraction plate or retainer plate that's trying to draw those slippers and therefore the pistons out. Well, if one piston seizes in the bore, well then all the neighboring pistons are going to come out, but that one, if it's stuck, one of two things is going to happen. Either that swaged joint between the piston and the slipper is going to be pulled apart, because generally these are just crimped over or swaged over to retain that socket joint between the piston and the slipper. And sometimes the slipper is the female or the male end, depends on the pump. This one, the male part of the ball is attached to the slipper. So this slipper went with the retraction plate, but the piston didn't. So that's kind of a common thing that might fail, and somebody might want to blame that slipper or blame the retraction plate. But in fact, dirty oil was the cause of this failure, some kind of contamination. Just the wrong particle size of dirt traveling through the system is going to get between that piston and barrel. If the particles are small, they can pass right through the system. Maybe they'll do some scoring or polishing of the metal parts, which is not good. It's going to wear out the pump. And if the parts are big and they don't fit between those clearances, then they're probably not going to cause an issue. But you get the wrong size part jammed between the piston and the barrel, and it almost like it's as good as welding it in there. So that's one type of failure. The other thing that can happen when you get a piston seizing up like that is a broken retraction plate or retainer plate. So these are generally made of fairly brittle metal. Looks like this one's powdered metal, so it's got some strength, but it's not pliable at all. If you try and bend it, it's going to pretty quickly break. So Often when a piston pump fails, someone will take it apart, they'll find a broken retraction plate. Because again, if one piston doesn't want to come out and the two neighboring pistons do, then that's going to try and bend that retraction plate. And of course you try and bend something that's brittle and it snaps. So I've seen lots of failures blamed on this part that was brittle, or something, because it's the only broken piece you find when you take the pump apart. But that's generally a result of dirty oil. And with this particular pump that I've got apart with the slipper that's popped out, it doesn't look like it has very many hours on it at all, so I'm not sure why the oil would have been contaminated. But if you've got a lot of hours on a pump and the oil's been dirty over a long period of time, sometimes what you'll see as well is wear around where the slippers ride inside the retraction plate. If you've got a lot of fine contamination in the case of the pump, it will polish that up and make even a recess to kind of mill. The slipper will actually sort of mill in there, especially if there's sand in the oil. This retraction plate or retainer plate I've got fairly typical wear. If the oil's been clean and you've got high hours on a pump and it's being rebuilt on schedule, you might see something like this where there's some polishing there, but it's not milled in. There hasn't been abrasives in there that have caused the slippers to machine their way into that plate. The other place in the pump that can be an indicator of dirty oil is where the lip seal rides on the shaft of the pump. And here we've got some polishing, which is pretty typical. If you've got deep grooves worn in there where the seal lips ride, probably don't have to tell you that soft lips of a static seal can't cut into hardened steel pump shaft. But what can wear grooves in a hardened steel pump shaft is abrasives. So if there's dirt in the oil, and specifically sand around this area, then that can be an indication that the maintenance on the lubrication system hasn't been very good at all. Or someone's been adding oil to the system and not paying attention to the cleanliness of the oil or the funnel or the tools, etc. But there's nothing, this one doesn't look drastic, so it seems like it was a very short duration that this pump had dirty oil in it, but just the wrong size particle gets in there and the pump can lock up. I don't see a lot of sort of sandblasting on the pistons themselves either. Got a piston from another pump that failed. Again, slipper came off. On this one, the slipper has the female part of the crimp or the swaged connection. And you can see it broke a piece of the slipper away when it came apart. And on this one, the camera's going to pick it up. It's got some corrosion on it now from sitting around, but you can actually see a lot of longitudinal scoring along the piston, along its length, indicating that there was dirt in there. And sometimes what you'll see is just a piston that's all frosted or sand almost looks like it's been sandblasted, which is an indication that there is sand in the oil. And sometimes you'll actually feel the grit when you take the pump apart. You may actually feel that the oil that's in the pump feels gritty, which can be a good indication of the cause of the failure. So again, maintenance with piston type pumps has to be a lot more precise than with a gear pump or even a vane pump. Vane pumps are a little more finicky than gear pumps, but piston pumps are very sensitive to contaminated oil.